So in this video, I'm giving you an exercise which combines some differentiation and some algebra. So what I'd like you to do is to calculate the derivative here of 2 times the logarithm of the modulus of the square root of x plus the square root of 1 plus x. So have a go with pen and paper, and after you've done that, come back and watch the rest of the video, where you can find a detailed solution. But before you do that, have a go and pause the video. Okay, welcome back. On the next slide, let's solve this problem. So here is the exercise again written here. And we have in front of the logarithm a factor of 2. And there are two things you could imagine doing with it. One might be to bring the 2 into the argument of the logarithm and square it, because 2 times the logarithm of something is the logarithm of this squared. But if you square this, you would get x, and you would get plus 1 plus x, but you would also get cross terms, so 2 times x, square root of x, times the root of 1 plus x. So you're going to get something which is not going to be very nice, and I don't think that's a good idea. So instead of that, what I want to do is just to pull the factor of 2 through the derivative, and that just makes it look slightly less threatening, and we have the hope that the factor of 2 later on is going to cancel something. So we're going to be looking at the derivative of this argument. Now, what we have here is a function, the logarithm of a function which is the sum of these two roots. So we're going to have to use the chain rule. So what we will do is we are going to get 2 times 1 over the argument, because when you differentiate a logarithm, you get 1 over that argument. So that's root x plus root of 1 plus x. And then because we're using the chain rule, we now multiply by the derivative of the modulus here. So the argument of the modulus. And the argument of the modulus is the sum of the roots. So just what we've written here. So this is the derivative of root x plus root 1 plus x. And if you are differentiating the sum of two terms, you just differentiate this and then add to it the derivative of this. So here we have root x, that's x to the power of a half. So we're going to get a factor of a half, which will cancel with this, times x to the power of a half minus 1, so x to the power of minus a half. And we're going to get something very similar here. So both terms will have a factor of a half, which will cancel with the 2. So that's nice, and let's see what happens apart from that. So we have 2 times 1 over this square root plus the other square root of 1 plus x, multiplied by, so let's open a big brackets, and it's a half 1 over root x plus, and then for the second term, again we have 1 plus x to the power of a half here. So when we differentiate it, we bring a half in front, and we have 1 plus x to the power of minus a half, and again that means 1 over root 1 plus x. And then what you might say is that from the chain rule again, we need to multiply by the derivative of the argument of the root, which is 1 plus x, and that's completely correct, of course, but the derivative of 1 plus x is 0 plus 1, so this factor is just equal to 1, and we don't need to worry about it. So we have the sum of these two roots. We have a half as a common factor for both terms, so the half factor could be brought outside, and it would cancel with the 2 in front, so let's just get rid of them immediately. And now this is our answer, 1 over this, times the sum of this term and this term, and we could write it out nicely and neatly on the next slide, but it's still pretty horrible looking. So to try to tidy it up, let's put these two terms on a common denominator and see what that looks like. So what we have is 1 over the sum of our two roots, root x plus root 1 plus x. And the common denominator here, because these two factors are just this and they're different, is going to be their product. So it is going to be root x times root 1 plus x. So for the first term, 1 over root x, we have got to put in the numerator a root 1 plus x, so that would cancel with this, and we would be left with 1 over root x, that term. And for the second term, in the same way, we need a root x, so that would cancel with that, and this part would be equivalent to 1 over root 1 plus x. And now when we look at this, we are, I hope, ecstatic, because this factor here is going to cancel with this factor here. Because here we have root x plus 1, root of 1 plus x, and here we have the sum of the same two terms. It's written in a different order, but that doesn't mean anything. This and this are the same thing, and they are going to cancel. So our numerator is 1. So this tells us that our answer is that the derivative of 2 times the logarithm of the modulus of root x plus root 1 plus x is equal to 1 over root x times root of 1 plus x. And that is our answer for this derivative. So, what did we do on this slide? First of all, we realized that taking the factor of 2 into here and squaring the entirety of the argument would not be a good idea, because you would get cross terms of roots which are not going to be simple. So we just pulled the factor of 2 through the derivative. Then we used the chain rule. The derivative of the log of the modulus of something is 1 over the something multiplied by, from the chain rule, the derivative of the something again. And then here we just said, well, the square root means this to the power of a half, and we just carried out the differentiation. Here we thought, let's be careful. The derivative of 1 plus x needs to be here, but that's just a factor of 1. And then when we cancel the 2's with the half factors, we put these terms on a common denominator, and then we saw that the factor in the numerator that we obtained cancelled this factor in the denominator, and in that way we were left with a relatively simple expression for our result. Okay, on the next slide I'm going to give you an exercise to solve and an answer. So here is an exercise for you, and what I would again suggest you do is just try it now with pen and paper, and then you can come back in a few minutes having done that, and you can see if you've got it right or not. So I will write the answer, but please try it before I do that. So pause the video. Okay, welcome back. And the answer that you should obtain is that the derivative of this ratio is 1 over 1 plus x squared, all to the power of 3 halves. And to do that, you're going to be using, well, the way I would do it is I use the product rule and the chain rule. So I view this as x multiplied by 1 plus x squared to the power of minus a half. And that's going to give you the sum of two terms. Again, put them on a common denominator, and you will see that there is a cancellation and it tidies up very nicely to that. Okay, with that, I will stop this video.